What's happening, dogs? Mr. Allen here, about to have an absolute blast with you guys in this video. We're going to be solving absolute value equations. All right, so we're going to solve each one for x. So first one here, I've got the absolute value equals 19. So since the absolute value of 2x plus 3 is already isolated, it's on its own, I can split this up into two separate equations and solve for x. It's double the fun here, man. Double the fun. So we've got 2x plus 3 equals 19. That would get this thing to work. But if I also got the inside of this absolute value to be negative 19, right? 2x plus 3, hang with me for a sec here. If I got that to be negative 19, the absolute value of negative 19 is 19. All right, so we got to set up these two situations here because the absolute value makes whatever's inside there positive. Once we evaluate, positive, okay? So if I can get the inside to be 19, it works. If I get the inside to be negative 19, also going to work. All right. So I'm going to subtract 3. And we get 2x equals 16. Divide by 2, I get x equals 8. Woo! If I plugged 8 in, 16 plus 3 is 19. Absolute value of 19 is 19. Next one, I got 2x. I'm going to subtract 3, I get negative 22. Divide by 2, I get negative 11. If I plug negative 11 in, 2 times negative 11 is negative 22, plus 3 is negative 19. Absolute value of negative 19, oh my goodness, is 19. They both work as they should. All right. Beautiful, fantastic, and wonderful. Next one over here. My absolute value this time is not on its own side. That's our first step. I got to get the absolute value isolated before I break it into two different equations. So I'm going to add 7 on both sides here, and we're going to get the absolute value of 3x plus 1 is equal to 28. Okay, cool. Is my absolute value on its own side? Yes. Can I split this up into two separate equations? Absolutely. I didn't mean for that one, okay? I didn't mean to do that one with the absolute joke. All right, so we got 3x plus 1 is equal to 28, and we got 3x plus 1 is equal to negative 28. I've also seen people switch the signs on the left side, but then you got to do it to both. It's kind of weird. This is my preferred method, right? And I'm making the video, so deal with it, bro. All right. I'm going to subtract 1. Subtract 1. I get 3x equals 27. Divide by 3. I get x equals positive 9. If you plug that in, I get 27 plus 1. That's 28. Absolute value of that is still 28. Minus 7 is 21, okay? We don't have to always check it. You can, okay? But you don't always have the time necessarily on a test. There's one red flag we're going to look out for, and I will talk about that in a moment, okay? Subtract 1. We get 3x equals negative 29. Divide by 3. Divide by 3. And I get x equals negative 29 thirds. And you might be like, bro, I got a fraction? That doesn't sound good. A lot of times with these problems, you are going to get one of the answers is a fraction. Not always, but just a lot of times it does happen. Like the first one we didn't. But it does happen over here when you get this going on here. But if I plug this in, the 3, when I plug in this, would cancel out. And I'd be left with negative 29 plus 1 is negative 28. Absolute value, that's 28. Minus 7 is 21. So it does work, okay? So don't be alarmed if you get a fraction in these. It does happen from time to time. Not a big deal. All right. This bad boy here. Ooh, we got a bit going on, man. We got a bit going on. We got a number out in front, like a coefficient out in front of our absolute value. That's pretty crazy. I'm not going to distribute that in. I'm leaving it out front, okay? So I'm going to subtract 2 first. I'm going to try to isolate my absolute value. I've got 3, and then we have x minus 6 equals 12. Then I'm going to divide by 3 to get my absolute value alone. And now I have the absolute value of x minus 6 is equal to 4. Absolute values alone, I can break this into x minus 6 equals 4 and x minus 6 equals negative 4. Then I'm going to add 6, and I get x equals 10. Over here I'm going to add 6, and I get x equals 2. Plug them in. They will both work here. Dope. Awesome and fantastic. All right. Last one here. I'm going to subtract 12 on both sides because this is not alone yet, right? It's not alone. So subtract 12 and I get the absolute value of 5x plus 2 equals negative 8. So do I have my absolute value isolated right now on its own side? Absolutely. Could I break this apart into two different equations right now? Absolutely. But hold up, okay? what is an absolute value always going to do to the stuff on the inside, right? Anything I plug in here for x, if I said, you know, negative 10, I'd have negative 50, plus 2 is negative 48, but it's going to make it positive 48, right? Anything I have in here, it's going to make it positive in the end. How is that ever going to equal negative 8? It's not, okay? So could I ever have an x value that goes in here, and then we do the absolute value of it to equal negative 8? It's not possible, man. No solution. Now, you could have gone through this entire thing here, and then when you plug back in, you'd start to see, like, wait, I'm not getting the right answer. I'm not getting 4 on my right-hand side, right? Or on the left-hand side, equaling the right-hand side of 4. It's because of this whole thing right here. So if you notice this, you have an absolute value equal to a negative, right? The absolute value has to be isolated for us to analyze it this way. If the absolute value equals a negative number, it is no solution. It cannot happen, okay? Cool? Awesome? Fantastic. America.